रात और स्क्रीन की रोशनी, सिंटैक्स की उलझन, प्रांशु का ज्ञान, एक एक लॉजिक आराम से समझाना। हाँ, मैं हूँ तुम्हारा गाइड यहाँ। ये डिजिटल सफर अकेले नहीं, लेट्स डिबग इट टुगेदर माय फ्रेंड। ये डिजिटल सफर अकेले नहीं, अकेले नहीं।
If you've ever looked at a screen full of raw code and felt immediate anxiety, you are not alone. To most people, it looks like an impenetrable wall of complex mathematics. This animated diagram illustrates the real issue, a strict translation gap. We think and speak in natural languages, but computers can only process electrical pulses represented as ones and zeros. C programming was designed to be the ultimate bridge across this exact void. Best of all, you don't need a single minute of prior experience to start using it. Programming is not about being a math genius. It is simply learning a new conversational language to talk to machines. Historically and architecturally, C is considered the mother of modern software development. Looking at this technological family tree, you can see C sitting directly at the root system. Once you build a strong foundation here, branching upward into popular languages like C++, Java, and Python becomes a frictionless process. Whether pursuing an engineering degree, a BCA or MCA, or just starting in school, mastering this logic is a mandatory step for most technical careers. C is not an outdated subject to skip. It provides the syntax and memory management logic that every higher-level language is built upon. It is easy to assume programming only lives behind a computer monitor, but C is quietly running the physical infrastructure all around us. Since the early days of automated banking, secure embedded systems written in C have managed our daily financial transactions. It also provides the exact control logic required for heavy industrial automation and robotics. In fields where there is zero margin for error, like life-saving medical devices and pacemakers, developers rely on C for its stability. Even complex modern IoT devices and autonomous vehicles use it to process microsecond decisions on the road. All of these massive physical actions trace back to tiny embedded brains, microcontrollers and processors, which run almost exclusively on C. When you learn this language, you are learning how to directly control the physical hardware of the modern world. So how exactly does human-typed text actually transform into instructions that drive a car or operate a robotic arm? It requires a specific engine called a compiler. In this flowchart, you can see the translation process in action. The compiler takes your readable C syntax, processes it, and permanently converts it into a stream of raw binary machine code that the hardware can execute. Throughout this course, we will use VS Code, a standard tool in the industry, to harness this compiler. Understanding the compiler removes the mystery from programming. It replaces the feeling of magic with a highly logical sequence of commands. This tech tree visualizes our exact roadmap. We start at 0 on the first tier: variables, data types, and operators. Next, we build logic with input-output, if-else statements, and loops. From there, we tackle intermediate data mechanics, arrays, strings, and functions. Finally, we reach the highest tier: pointers, structures, file handling, and dynamic memory allocation. By following this sequence, what initially looks like thousands of lines of abstract text resolves into a set of distinct, predictable patterns. Completing this roadmap culminates in the ability to build functional, real-world projects entirely from scratch. Those project-building skills translate directly into the knowledge you need to confidently answer technical interview questions. If you are ready to commit to this journey, drop a comment below letting me know your class or college. In the very next video, we will bridge the gap from theory to reality by installing the compiler and writing our first line of code. Welcome to your new language.